Operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REX spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected, as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze. The surface today was probably a little bit soft, so it looks like it's resting a little bit far off the actual desert. It doesn't appear to have dug in too much with that nose cone from the heat shield. You are here with us as we witness this historic moment. It's the first time the United States has delivered samples from an asteroid to Earth. And these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range, and then also make sure that that SRC is safe for our operations team to approach and begin recovery. You can see where that parachute disconnected from the top of that SRC. That is the back shield that you see right there at the very top with that little bit of white wiring still coming out of the top. Our SRC perfectly landed there on the Utah Test and Training Range. So what you're about to see happening next is the process of recovery operations. This is a key moment of today's events to actually get that SRC from out in the desert into our portable clean room here at Dugway. It is crucial that we maintain the pristine nature of this sample that we got back from asteroid Bennu. It could hold the clues to how everything around us came to be, from the formation of the planets to origins of life here, so the team understands just how crucial the contents of that SRC is, and they're going to work as efficiently and as safely as possible to get that SRC contained, wrapped up in thermal blanketing, placed in a sample carrying fixture, and then attached with long line to our first helicopter there. It'll then be transported the long journey back here, a much more relaxing flight, I'm sure, for our SRC, to our portable clean room at Dugway. At which point the team members will extract the back shell and remove the heat shield from the SRC. It's served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the Asteroid-REX out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge, and this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Kilos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations. At least from this perspective, I'm not noticing really any drag marks or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by our recovery team and will be passed off to the sample curation team at the Johnson Space Center. As they begin to unload and actually open up the sample canister there, exploring the contents within and making sure that no possible contaminants from the surrounding landing location got into our sample. We're getting a wider view now. We should have the helicopters that have landed nearby coming into view, potentially. The team really taking extra precaution as they approach the SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that re-entry. We'll also be making sure that there is no live voltage present. And we see a view now from our high altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walk the 2WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes as the team actually will be setting up a camera on the ground for us to observe the recovery operations close up. And a note from one of the team members about the SRC itself. So they have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned before, that sample return capsule is a complex network of piping and tubing inside of it, sort of like a labyrinth-like design, and that is intentional to make it incredibly difficult for any possible contaminants from the atmosphere to get into our sample canister. So sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within. The main goal, as I said, for today is to get that sample canister on a nitrogen purge. That is to maintain its pristine nature. And we have visual once again from one of our helicopters here orbiting around the landing location. You can see our SRC at the bottom left of your screen and its parachute that helped us get the last leg of the journey down. It deployed a little bit higher than we expected, 20,000 feet elevation. Original expectation was at about 5,000 feet. And this brought us down the last leg of the journey. after a punishing initial entry into Earth's atmosphere over San Francisco, about 82 miles in altitude, to now resting on the rugged Utah Test and Training Range desert floor.
Recovery operations. Recovery team is in the vicinity, beginning their initial assessments.
So you just heard confirmation from Tim Prizer that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, Oscar, Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go. On screen, you can see front and center there, Stu Wiley, our on-scene commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during re-entry. You can see him scanning the region. He is checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar is performing the unexploded ordnance survey.
And you just heard that he is, in fact, doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey, the OSIRIS-REX spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed. A little bit closer. Stu continues to pace around the surrounding area. All over here, the team will collect samples. He'll begin to place flags. You can see in his backpack, he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100 degrees Fahrenheit.
Lockheed Martin Safety is performing hazardous environment assessments.
And you just heard that confirmation. So she is performing that hazardous environment assessment, checking the thermal temperature of that SRC, as well as taking any kind of gas readings to make sure that we are at safe operational levels. She is also leading over. This is Victoria team from Lockheed Martin. Stu continues to sweep the area around her for the safe operation of our recovery crew members. There are several nozzles, valves around the SRC, and so once Victoria has the clear to approach, she'll actually open up some of those valves and insert a gas reading device within to actually take some temperatures. And you can see off to the left of your screen, Stu Wiley is actually safing and stowing away that parachute that helped take us the last leg of the journey. It's great news that that disconnected from the SRC. That allowed our SRC to rest as it is now here on the surface of the Utah Test and Training Range. It appears with minimal dragging.
Recovery operations. Oscar is safing and storing the main parachute.
So Stu is going to get that parachute stowed, placed away, as Victoria is front and center on your screen, beginning to take some of those gas readings to make sure that we are not outgassing any kind of noxious chemicals that could be present from that battery heating up within the SRC. And Stu is walking back to the team with that parachute. So the SRC battery is comprised of lithium disulfide, and as such, the possibility of toxic vapors exists if the battery packaging has been damaged during entry or landing. Discharging could cause potential presence of hydrogen sulfide from those batteries heating up, or carbon monoxide. And so that is why Victoria initially had her gas mask on. It appears she has now actually taken it off, so it appears that the gas readings indicate nominal conditions.
Recovery operations. Lockheed Martin Safety has confirmed no hazardous gas.
And you just heard that confirmation, so the safety assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery operations and actually get this SRC into our clean room here at Dugway and continue the operations. You can see the Lockheed Martin team in the bottom left of your screen, just overjoyed with this moment. This is years of careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we actually will begin our recovery operations, a key part of today's events. And you might see Victoria approach over and over once again to that SRC to continue to take gas readings. At this point, she appears to be covering up the back shell of that SRC, placing a Teflon cover over. This is where the parachute actually deployed at the top of the SRC capsule, the sample return capsule rather. She'll also be checking for any possible live voltage, and we'll wrap Kapton tape around the 2 cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell. And she has successfully placed that shielding on the back, that Teflon cover. Stu walking around behind, checking the rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria opening up a couple gas valves on the SRC, taking those gas readings. She'll continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC. She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Wow, thank you, James.
Oh,
can you believe it?
OMG. Touchdown for science.
What a deal. And they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all breathing a big sigh of relief. Obviously, we're not completely out of the woods here, and we'll be monitoring what's going on and keeping you abreast of everything that's happening. But for now,
wow,
we made it home.
A great job by that Lockheed Martin team,
yes.
safing that craft.
Fantastic work.
What a spacecraft. We have to name her specially.
Yes, absolutely. In that capsule, everything perfect. So while the capsule was making its way to the ground, mission teams...
Recovery operations, all vent covers are in place.
All right, so we're making progress.
We're making progress.
All right, so while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and nurtured this mission for more than 7 years of spaceflight, and even longer in terms of construction and design. Gosh, wow, amazing.
11 years since it was selected to fly. What a job, folks.
Just fantastic. A lot's happened in 7 years. All right, so let's get an update from where the action started this morning. Sophia, tell us everything.
Okay, firstly, I want to say we are so grateful that the capsule is on the ground and in good hands now. Now, from here, from Wig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast ancient seabed. So the mountains that are peppering along the edges over here, they are very muted colors. It's beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully, we got that great image from the NASA helicopter. Wow. Just well done to that team. Thank you for that. So while we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody, congratulations to the OSIRIS-REX team. You did it. You designed it, you built it, and you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues with incredible science and analysis going to come. But I want to thank you all for everybody that made this OSIRIS-REX mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic, fantastic news. All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REX moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have 2 of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Suni Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Suni, thank you for joining us.
Oh, we are honored to be here.
Super exciting day. Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It's like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, we've both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal,
obvious.
Pretty close to exciting and intense, and that parachute opened, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
The recovery team is performing their safety.
This is a beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this capsule too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So you guys will be coming back, and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon, and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise woman.
I'm super glad the spacecraft did it, and we'll set the pace and show us how to do it. But
Absolutely.
I think maybe you'll practice a little bit more before we go, because it's
idea.
a dangerous environment learning about it.
So
much
Sunny and Butch, thank you so much for joining us today.
appreciate it.
You'll stick around for more of the show.
Yeah,
All right, congratulations,
Thank you, guys.
everybody out
Thank
there.
you
Really
so
appreciate it.
much.
Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REX asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here, that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow. Absolutely gorgeous. The spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a landing, as opposed to an ocean landing?
Right. So many of our crews land in the ocean, as you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look. When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS-REX is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REX. After today, NASA and Dugway are looking towards the future, to the Mars sample return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery operations. Nominal SRC recovery operations have begun.
Getting an update. Okay. All right, nominal SRC recovery operations have begun. Okay.
Pretty darn good.
All right. Okay, so today could not have gone any better. How did it, I mean, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter, and so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though. Yeah. So close.
So we have a big collaboration at NASA with members of from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world. The types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that's really allows them to hone those problem-solving skills.
Right.
So that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well, there you go. There you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today is your birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No. And this is the rarest stuff we've ever had on Earth.
It is. And I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high, really, and so my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool,
yes.
too.
Yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you so much.
We have a saying at NASA that the only way to reach the stars is if we all go together. The OSIRIS-REX team represents pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway. It's a wonderful base. To have it be a prominent area where this is coming down is really amazing to us.
Well, I'm just glad that this little town is getting noticed.
It's a big rock that has kind of like holes in it because they've been flying through the sky with fire because it goes really fast.
Honestly, I find it really cool because you don't really expect this stuff to happen, in your backyard. But I really wish I could see it, but I don't know. I'm going to try my hardest.
I became interested in the mission because I have the NASA app and I get daily updates on photos, and one day I saw a photo that had that Dugway, Utah titled on it, and I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool.
Let's go OSIRIS-REX!
Go OSIRIS-REX!
Let's go OSIRIS-REX!
Let's go OSIRIS-REX!
Let's go OSIRIS-REX!
All right, let's go OSIRIS-REX. I love that energy.
I do too.
All right, Jim, you're a planetary geologist. How did you get into this? I mean, these kids are just at the beginning of thinking about what their career might be. I mean, how did you do this?
I think all kids are intrinsically curious at birth. My mother said I was interested in space at birth. Don't know how she knew. But in any event, I think we all are, and we follow different pathways. If you see things as beautiful as we have here in Dugway, here in Utah, you'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lauren, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also, just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately, so everything was right there working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery waiting for us about the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology would continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS-REX samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born asking questions we can't even begin to imagine. Recovery operations will begin. You'll see a number of team members come out here. They'll be carrying with them a carrying fixture. It's a large metal fixture that has been perfectly designed to have our SRC resting within. They'll be bringing out a lot of thermal blanketing that will be used to protect our SRC during its flight back to the clean room here. Again, we want to make sure that that SRC is safe from any kind of possible contamination from the atmosphere. So they're going to do an excellent job of actually wrapping this SRC up and getting it prepared to transport to our portable clean room. That actual operation of getting that SRC bagged and stowed and ready to go on our long line operations for the helicopter will be a rather quick operation, as you see some team members from Lockheed Martin. Their role is largely finished for today. They were operating a lot of the flight dynamics of that SRC, getting it to the ground, and now they can really just take a step back and relax, catch their breath after all the chaos of the morning. Very exciting moment for all of them, I'm sure, to actually see their creation sitting on the surface of the Utah Test and Training Range. Just massive, massive sigh of relief. So as I mentioned, that actual recovery of the SRC will be a relatively quick process, but a number of our team members, including Dante Loretta, our principal investigator, might remain out on the site where you see that SRC on your screen now. They're going to continue to collect samples. You can see a number of flags placed around. There's some pink flags placed there. There are 4 placed in front of the SRC where the team believes the SRC is potentially dragged along the surface as it came to a rest on the Utah Test and Training Range desert surface. On the back side of that SRC are 4 additional pink flags, and those are our regions for control sampling. We'll actually go and sample all of these regions and compare back to areas we believe the SRC did not contact. You can see additionally, it's a little bit hard to make out with the bright color of the desert, but there are a couple white flags present at the SRC. And these are areas of operation for the team to actually be able to walk up to the SRC with the carrying fixture, place it next to the SRC, and actually begin to bag and stow our sample return capsule for transport to the Dugway clean room. So it's been already just an incredible morning. We're now about an hour past landing of the OSIRIS-REX sample return capsule Just a few years ago, our spacecraft, our intrepid robotic explorer, was 200 million miles away from us on the other side of the solar system. It successfully captured a sample of the asteroid Bennu, stowed it away, and transported it on the long 1.2 billion mile journey to us here on Earth. We experienced an incredible entry command to actually release the sample return capsule containing pieces of the asteroid Bennu. It then floated on its own through the vacuum of space for about 4 hours before coming in contact with the atmosphere over the San Francisco, California Bay Area, traveling at just over 27,000 miles per hour and heating up to over 5,000 degrees Fahrenheit as it encountered the incredible drag forces our Earth's atmosphere presents. We then slowed down under our drogue parachute initially, which kept us stable during our descent down to the Utah Test and Training Range. And then ultimately, at about 20,000 feet off the deck, we gave the command to deploy our main parachute, that orange creamsicle color parachute that has now actually already been stowed away by our team members here at the Utah Test and Training Range. It's been a really wild journey. Very excited to have our SRC on the ground. And you see a view of our mission operations team observing our recovery team that is already out on the landing zone, taking samples, beginning to actually prepare the thermal blanketing, the protective layers for our SRC, and you can see we're documenting this whole process along the way. And so these operations will continue for the next couple minutes, or as long as it takes to safely store that SRC and prepare it for long line operations to get it to the clean room here. We'll continue to take samples, and I will continue to monitor the situation as we proceed here. But for now, back to you, Lauren and Jim.
Thanks, James. And just a reminder to those watching, we are in an extremely remote location. And so if our signal is breaking up, it's because we're out in the middle of nowhere. So we're doing a great job, all things considered. One other thing that I wanted to address really quickly is that parachute ended up deploying really quickly. Did it not, Jim?
It did. It deployed high, and this is a smart spacecraft. That sample return capsule detected the acceleration rate, and it decided that it was important to get that parachute out to slow her down so we could make this beautiful, safe landing. And that's the way this magical autonomous spaceflight works these days. We adjust to the dynamics of the environment. Again, hats off to the engineers that built those systems in so we could be home safe doing what you can see on your screen now.
With a beautiful landing. All right, Jim, let's actually take some social media questions now. Let's get our first one. All right, at CCSV wants to know, will the sample be quarantined like moon rocks are?
Well, in this case, based on a classification of what we call the planetary protection, these samples will not be quarantined in that way. The first moon rocks came back, they were quarantined for a week, out on the carrier and all that kind of good stuff, came back to Houston again very carefully. In this case, we understand the asteroid, the environment, we measured it with OSIRIS-REX, other asteroid samples from our colleagues in Japan, and so we don't have to quarantine them the same way. We do have to protect them though from contamination, and there's all kinds of systems in place by our team to allow us to understand the level of contamination. So what we study in science is the pristine asteroid.
That was a great question.
Excellent question.
Excellent question.
Recovery operations. SRC is bagged and secured in the handling fixture.
All right, you just heard that the SRC has been bagged, and we are well on our way to getting that to our clean room here at Dugway. Wow, fantastic news. Missions like OSIRIS-REX transform scientific pursuits into engineering challenges. Smart, curious people pursue answers with creative verve and perseverance. This year, Hollywood also had a story about a crowd of people situated around the touchdown point of an asteroid. And, well, we couldn't help ourselves. We asked the cast of Asteroid City to say a few words. All right, well, it looks like we are having some technical difficulties, but that's okay. We'll definitely get you that video. It's a really fun one.
It is.
Scarlett Johansson, I mean, A-lister,
yes.
Can you imagine? All right, so let's get an update from our field correspondent, Sophia. Sophia, do you have an update for us?
Okay, Lauren, turns out the landing site really is just over my shoulder. It is just so hard to see through the alkaline particulate out here on the landing zone. But you know what? This is all in great hands, and we are just very thrilled that the capsule is doing well today. So I'm able to see one of the helicopters just circling over there. But for those of you who have just tuned in, I am on Wig Mountain, which is overlooking the ellipse, which is the vast landing zone. And earlier today, the helicopters, which were shuttling our teams of experts and our scientists, departed from here via helicopter once they found out exactly where the capsule landed, and now they are off on their recovery process and are doing what they do, which has been a carefully rehearsed process. So, Lauren, I'm going to send it back to you.
Great. Thank you so much, Sophia. All right. Well, let's get back to that awesome video of Asteroid City. You don't want to miss this. Take a look.
Hi, I'm Jason Schwartzman.
I'm Jake Ryan.
And I'm Scarlett Johansson.
Where are you?
Asteroid City, Farm Route 6, Mile 75.
Hey everyone, I'm Jeffrey Wright. Junior stargazers and space cadets. Each year we celebrate Asteroid Day.
Hey everyone, I'm Maya Hawke.
And I'm Rupert Friend.
And we star in Wes Anderson's new movie, Asteroid City.
In the movie, families from across the country gather in a fictional American desert town for a junior stargazer convention.
I heard there's a real-life reason people will be gathering in the Utah desert this September.
The world will never be the same.
What is happening there on September 24th?
September 24th is going to be a historic day. This is NASA's first asteroid sample return mission and the biggest sample return beyond the moon. Shortly before 9 a.m. local time, the OSIRIS-REX spacecraft carrying precious samples of asteroid Bennu will release the capsule into the atmosphere to lower the samples down to the Utah desert, where scientists are anxiously awaiting the return of these materials.
Wow, that sounds like the plot of a science fiction film.
It's incredible that a spacecraft can go to an asteroid,
grab some pieces of it, and then bring them to Earth.
So what will NASA look for within the asteroid sample?
These pristine asteroid materials will be studied by scientists from around the world. We're going to be looking at the minerals. We're going to be dissecting the rocks, looking at it mineral grain by mineral grain to learn more about how the solar system formed and evolved. We're also going to be looking for water to try to understand how our Earth's oceans came to be. And then finally, we're going to be looking at organic compounds, including some of the basic chemical building blocks of life, to try to understand whether asteroids like Bennu could have delivered the building blocks to Earth, leading to the origin of life on Earth and potentially elsewhere. With the data that we obtain from these materials, we're going to be rewriting the textbooks on solar system formation.
Fascinating stuff. But don't fragments of asteroids land on Earth all the time? Why can't we study those pieces instead of a mission to bring this sample to the Earth?
Yeah, that's a great question. I mean, in fact, the Earth is constantly being bombarded by fragments of asteroids in the form of meteorites. But one of the big problems with studying meteorites is you don't always know where they came from, and it also can be contaminated.
Fair enough. It makes sense that we'd want to study something more pristine.
So how will NASA protect the sample once it's on Earth? And can I have some?
Oh, I wish we could have some of these samples. I wish I could bring one home with me to put on my dresser at home. But the reality is these samples will only be for educational purposes and scientific research. The samples will be transported to the NASA's Johnson Space Center, where they built a special curation facility just for keeping these samples safe and pristine.
This is also incredible. I'm so glad that NASA has teams of people that are searching for the answers to some of the biggest questions, like where did life and water come from? Where did our solar system come from?
I can't wait to see what we learn from the asteroid sample OSIRIS-REX is bringing to Earth. Thank you for all that you do.
This is also incredible.
Thank you so much for all you do.
Well, you just said that name. You just said OSIRIS-REX. That was the thing.
That was kick-ass.
How did you do that? I was like, what is this phrase?
I was like,
OSIRIS-REX.
OSIRIS-REX.
Yeah, OSIRIS.
It was great. It was great.
OSIRIS-REX.
Wow, talk about that mega wattage star
Whoa,
power.
Scarlett,
oh
wow.
my gosh. It takes a huge, talented team with profoundly diverse skills to design and execute something as audacious as OSIRIS-REX. It takes years of planning and perseverance to see it through from that initial notepad doodle to a moment when the world tunes in to celebrate a huge success. It also takes leadership. And I'm pleased to say that we are now joined by the director of NASA Goddard Space Flight Center, Dr. Mackenzie Lystrup. Welcome.
Yeah, thank you so much. I'm
Delighted to be here and very happy about the results coming out today.
It is a great day indeed, and congratulations. This is a huge day for Goddard. It must go without saying that you are very proud.
Absolutely. This team is amazing, Goddard, is that we have scientists and engineers working side by side. And so that doodle on a napkin can turn into something like OSIRIS-REX. And scientists like Dr. Garvin here, who's joined us, really help us create a vision with other scientists of how you're going to do the engineering that gets you to this moment that we have today.
And Mackenzie, we have leadership across all domains on this mission, from system engineering to science to accounting to everything. How did your team in Maryland pull this thing off?
Yeah, you know, we have people who have managed multiple parts of missions over the decades. Systems engineering is critical, and it's one of the things that Goddard really brings to the table. And systems engineering means that we take into account everything about the mission, from the science ideas to the launch to orchestrating the landing here on Earth, but making sure that all of the instruments are working together, making sure that the spacecraft successfully interfaces with the instruments and can carry out its job once it was at Bennu. All of that requires really understanding the entire system. So when we say systems engineering, we're really talking about that overarching holistic perspective that our scientists and our engineers bring to the table. But it's true that we have some of the greatest scientists and engineers working on space missions, and they pull it off every time.
Awesome.
Fantastic. Well, you know, really quickly here, Goddard will be one of the centers that will receive a sample, but who else will receive a sample of the asteroid?
Samples are really traveling all around the world. What I think is very exciting about this mission is that we're saving about 75%. And we're not sending that out yet. We're keeping that in storage for future generations to be able to use more advanced methods and instruments to be able to analyze. So about 25% of that material is going to be headed to scientific organizations all around the globe.
Fantastic.
Unbelievable.
Well, thank you so much for joining us this morning.
Yeah, thank you.
Thank you so much.
Congratulations.
Yes.
There's a big team of scientists, engineers, and so many others here in Utah working to make OSIRIS a success. It should go without saying, everyone here is mission critical, from bus drivers to planetary geologists, helicopter pilots to logistics experts. With all of the natural excitement about the mission itself, let's stop for a few minutes and highlight those in OSIRIS-REX who made it live and breathe. Take a look. Boy, it's really hard not to get a little emotional when you see all those faces. These are a lot of the people that we've been seeing over the last few days, and they're getting their time in the sun. All right, let's throw it over to James for an operational update. Take it away, James.
Yeah, thanks, Lauren. So while we've been kind of waiting for the past couple of minutes here, the team has actually successfully bagged and prepared the sample return capsule for the long line operations. You can see on your screen right now, the SRC is bagged within thermal blanketing, and that metal thing you see on the bottom is the carrying fixture. This will then be actually loaded up into cargo netting and prepared for long-line operations. One of our helicopters will take flight, carrying the SRC dangling beneath it. The SRC is going to be stabilized with that cargo netting. There is a gimbal that will keep it stable as we begin the flight to the clean room with our precious cargo on board. You'll notice a couple of tape markers on that SRC as well, the thermal blanketing there. Those are pieces of Kapton tape marking exactly where vents are on that SRC for team members here at the clean room, who will once again do gas and thermal readings once it arrives at the clean room. Just once again making sure team members are safe and secure as we begin to continue those recovery operations, getting the SRC into the clean room. And this is one of the last phases of the process of getting our SRC back and then opening it up, finally seeing that sample canister within and preparing that for shipment tomorrow on a C-17 cargo plane to the Johnson Space Center's sample curation facility. And this was a very quick process. I mean, if you're keeping time at home, this was only maybe about 20 minutes that they took to get out there once they arrived and wrap everything up really quickly once they were given the official confirmation to approach, get everything stored, prepared for those long line operations. This really has become second nature for these team members. They really are able to bag and prepare this SRC, and you'll see still quite a few flags around that area there. Once this SRC is flown away from the region, the landing zone, team members from the curation team will remain on site and continue to take samples of that surrounding area. They also have set up off screen here, you can't see it, but there is a air reading that they're going to be taking actual air samples of the area, atmospheric samples. All of this will be cross-correlated with samples that we actually get back from the asteroid Bennu to make sure that nothing from Earth here at the LZ or beyond got into that sample return capsule. And you can see some of those team members who are going to be taking those samples once again approaching the location. Dante Loretta is front and center with them. He has that armband on, and on his left arm you can see it there as he's carrying his bucket that has all of his tools that he needs to begin collecting these samples. It's a very tight procedure that they have to go through to make sure that they are properly taking these samples. You can see they are photographing the area first, documenting exactly where they are collecting the sample from. They then have a small metal scooper that they'll use to actually dig into the desert surface. It's a bit of a soft surface out there today. As I mentioned, we did have some rain that softened it up, so it should be easy to dig in there, grab a bit of sample, and then they will bag that sample, seal it up, and then send that off to the sample curation team at the Johnson Space Center. Admiring the region as well. It's a beautiful, clear morning there today. We've been rehearsing in a variety of different conditions, including in the middle of the summer where temperatures were over 100 degrees Fahrenheit, much cooler conditions. You can see our team members wearing their UV shirts today. A much chillier morning for them as they are doing these recovery operations. And this process does take some time as they go through and collect these samples. They want to make sure that they are accurately documenting exactly what's present at this landing zone for the team members who are at the sample curation facility of the Johnson Space Center. We're getting a great aerial view from our NASA helicopter. They've been doing a phenomenal job all morning tracking the action for us, and we don't give them enough credit. We've been training, obviously, all of the science and
recovery
engineering
operations. The recovery team is moving the SRC to Helicopter 1 and preparing for long line operations.
And there we have it. We are going to be moving towards those long line operations. The rest of the team members approaching that SRC that has been successfully bagged and prepared to be loaded into the helicopter's long line. This will be the last time the SRC takes flight. We had a wild flight this morning. You can see two team members lifting that SRC up. It's about 120 pounds total once you have the SRC and the carrying fixture there together. They're going to be walking this over, preparing it for cargo netting, and getting that attached to the long line for helicopter operations. And as I mentioned, this is the last time the SRC is going to be taking flight. It had a harrowing journey this morning coming through the Earth's atmosphere at over 27,000 miles per hour. It is now being carried carefully by a couple team members here. So quite a deceleration from that initial entry, and really just a wonderful final journey for our sample before it is opened up at the clean room and prepared to be shipped to this to the curation facility at Johnson. And as I mentioned, this view is coming from one of our NASA helicopters. Just like the science and engineering teams have been preparing for this key moment, our NASA helicopter pilots have also been preparing to cover today's events. They're typically down at Kennedy Space Center in Florida, capturing launch coverage from Cape Canaveral. But this past couple months, they've been out here with us at the Utah Test and Training Range, preparing to document today's events, getting incredible footage for us all along the way. You can see those team members have a bit of a hike to carry it to where it is safe operationally. And you can see we have the cargo netting already laid out there. Our representative from Dugway, Jasmine Nakayama, is prepared with that cargo netting. She's going to help the team here get that SRC that has already been successfully bagged up with thermal wrapping into that cargo netting. And you can see the helicopter already there, staged and ready to lift off. The helicopter pilot has actually removed one of the doors on that helicopter so he can lean out and look down as he carefully lifts the SRC off the terrain. We want to make sure that this is a careful, slow process as we safely transport this SRC to the Dugway clean room. And you can see Jasmine is picking up pieces of the cargo netting and beginning to wrap the SRC that has been placed already on the carrying fixture with the thermal blanketing. Team members observing their handiwork of getting that carefully wrapped up. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations, SRC is in the cargo net, and all the gear has been stowed in the helicopter.
Great news, everything sounds nominal for helicopter operations, and in just a few moments we should have liftoff of that SRC aboard the helicopter with that long line attached. Team members clearing the area to make sure that we can safely take off with our helicopter. These helicopter pilots have also been training in tandem with all the team members the past couple months leading up to this key moment. We've practiced these long line operations, we've practiced the flight back to the Dugway clean room, but obviously nothing compares to the real deal. I'm sure they are feeling the excitement, they are feeling the nerves as they know how precious their cargo is this morning that they're transporting to the Dugway clean room. See, Jasmine is donning a helmet and the rotors are kicking on for our helicopter. Kicking off some dust as they get up to speed there. It is a dusty morning out on the desert. And this will be, once again, a very slow, deliberate operation. We want to make sure that sample return capsule is safe as we are lifting it off. The piece that Jasmine is holding in her hand right now is that gimbal stabilizer for the cargo netting. That will ensure that the SRC is not wildly spinning as we get to altitude with our helicopter. These helicopters can get upwards of over 100 miles an hour speed, but we're going to go nowhere close to that today. We're going to be taking this at a slow pace, making sure that SRC can get back safely and securely to our Dugway clean room. You can see one of our NASA photographers, Keegan Barber, taking some great pictures. I'm sure those will be phenomenal views of the operations that are going on just across the way from us at the Utah Test and Training Range. As soon as these rotors get up to speed, our helicopter will get off the ground. The terrain is a little bit soft today. Team members were out here yesterday testing out the grounds and had practiced actually landing with some of the helicopters. Those skids on the helicopters got about an inch into the wet terrain. It's presumably dried a lot more today. It's the sunny, clear skies have probably helped us out a bit, so this should be an easy liftoff for this helicopter to get into the air and help transport that SRC to the clean room. Off-screen, team members are presumably continuing to collect samples of the surrounding area, both environmental, soil samples, atmospheric samples. We'll be continuing to do those operations even as we bring this SRC to our clean room. Just a great view here from our NASA helicopter. And in just a few moments, we should have a stunning view of our SRC lifting off the ground. No part of this SRC comes in contact with the helicopter. As I said, it's been safely stored in that thermal blanketing. There's multiple layers of that blanketing, as well as a tarp being placed over it. Now, it is also in that cargo netting, thanks to our Dugway representative, Jasmine Nakayama. She's then attached this whole contraption to a long line that will dangle about 100 feet below the helicopter. And I can see a lot of dust kicking up now. The engine's really revving up on that helicopter, and it is off the desert terrain in the air with the SRC in tow.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And we have clearance to depart the recovery site. This is a key moment of those recovery operations. We're already getting that SRC out of the landing zone and on its way to the Dugway clean room. In just a few moments, that SRC with the long line attached will be lifting off its landing zone. Jasmine assisting with that final part of the lift, and it is now airborne. As I mentioned, a much more relaxing flight for our SRC on its last leg of its journey. We are officially departing that landing zone. Recovery operations will continue out at the Dugway clean room. I see team members waving goodbye. And look at that view. This is a stunning view of our helicopter. This is a long journey ahead. As I mentioned, probably about 20 minutes of total flight time. We may lose signal as we head out there a bit, but for now we have a stunning view of our helicopter carrying the SRC below, and you can see that stabilizer is helping to keep that SRC nice and stable below. We'll continue to track this transport to the clean room, but for now, back to you, Lauren and Jim.
Wow, check out that epic shot. Check it out.
What a ride.
Wow. All right. Thanks, James. The science community has serious questions about asteroids like Bennu for a long time. What are they made of? Do they hold any clues about the origins of life on Earth or elsewhere? And what can they tell us about our past and potentially our future?
It's all about chemistry, Lauren.
It absolutely is. Well, fortunately, Jim, we are joined by somebody who specializes in the kind of chemistry that you'd be hard-pressed to find outside of NASA. Jason Dworkin is the OSIRIS-REX project scientist. Welcome.
Welcome, Jason. Thanks for coming.
And congratulations. What a historic day.
Oh, it's
you must be so relieved.
Fantastic, yes. Relieved, invigorated, excited, and
As we
so
all
much
are.
work ahead of us.
Right.
Indeed, indeed.
Fun work.
Fun work.
No, epic work.
Epic work. You must be so excited to dig into the sample yourself. But what makes this sample? You know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically significant?
So Bennu is an ancient piece of the early solar system, a leftover component. It's a fragment of what happens when you make planets, and this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. Right. So by studying a sample from the leftovers of space, we can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail as you can only do on the ground, using instruments that are sometimes bigger than the launch pad, let alone the rocket and the spacecraft. So we can interrogate the compounds, the minerals in fine detail to understand how they interact with each other and how they could have led to the history of the solar system.
And that's forensic science at its best. But I have a question, Jason, because you're an expert in this. So we're going to save some of this sample so that future generations, future techniques, future people not even born can learn from it in the future as we try to look at our place in space.
Absolutely. That's one of the parts I find the most exciting and gratifying, is that the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways, just as we have for the Apollo samples. A woman in my laboratory studied Apollo 16 and 17 samples that were collected before she was born, using techniques that were not invented in the 1970s to then answer questions that were thought of but couldn't be answered.
That's
and so
incredible.
Since you mentioned forensics, we also have equipped future generations with the information to follow the chain of evidence from the construction of the spacecraft all the way to the collection now and then the distribution.
Awesome, Jason.
Wow, that is so cool.
Thank you.
Well, thank you so much for joining us.
Pleasure. Thank you.
Thanks, Jason. Good luck.
Careful handling of this asteroid sample is all about getting the most out of the huge effort to visit the object in the first place. Mission planners considered many destinations but settled on Bennu. Let's learn more about why. OSIRIS-REX was designed to retrieve a sample from asteroid Bennu and return it to Earth. So, of the more than 1 million known asteroids in our solar system, why Bennu? First, as a near-Earth asteroid, Bennu is easy to reach. It takes about 14 months to orbit the Sun and comes close to Earth once every 6 years. To get there, OSIRIS-REX was launched in 2016 on an Atlas V rocket with a single booster and a Centaur upper stage. It also got a big assist from Earth's gravity in 2017, allowing it to match Bennu's orbital tilt. The second reason that Bennu was chosen was its size and spin rate. Bennu measures about half a kilometer in diameter and rotates on its axis once every 4.3 hours, which is actually pretty slow compared to many smaller asteroids. This allowed OSIRIS-REX to map Bennu's surface up close, and to match its velocity, briefly touch down and collect a sample. Before OSIRIS-REX arrived, scientists thought that Bennu's slow rotation meant a low risk of flinging away most of its sampleable material. But shortly after arrival, Bennu was caught on camera ejecting hundreds of pebbles. It turns out that Bennu regularly sheds small particles, but it still had plenty of loose material left on its surface for sample collection. The third reason for choosing Bennu was its composition. We don't know what ingredients were present during the formation of life on Earth, but primitive asteroids like Bennu serve as time capsules, preserving material from the dawn of the solar system. Spectrometers on OSIRIS-REX confirm that Bennu is rich in carbon-based molecules, including organics that are the stuff of life. When the Bennu sample is analyzed, it will help scientists to better understand the formation of the solar system and our own origins. So why this particular asteroid? Proximity to Earth, the right size and spin, and a carbon-rich composition. That is why we chose Bennu. As you can see in the bottom of your screen, that SRC is continuing its transit to the clean room.
Awesome.
All right, so turning our attention back to the rocks in the Bach, I have to ask Jim, how did they get it in here? What is this?
So this is the TAGSAM sampler head. It's about a foot long. It looks like an old Chevy carburetor, but inside is something much more precious. Inside, maybe 250 or more grams of that primitive material from the asteroid. And it has all the gear on it, including samplers on the bottom, little pads to grab sample, as well as the stuff inside that contains the bigger pebbles and all the dust. It even has witness plates that we use to do that contamination control that Jason was talking about. This is the box.
Mm-hmm. This is the big deal right here. And you know, the material went into this box. We've actually got some of what's called simulant here, and this is obviously not the actual sample from Bennu, but it is a good approximation. Is that right, Jim?
That's right. And so what we discovered on this amazing mission was the material properties and the microgravity of asteroid Bennu didn't behave like we totally expected. They behaved like an almost cohesionless fluid. And so while I pour this here and they fall pretty naturally, and this is about the amount of stuff we expect to find inside this sampler head, they flowed more like water on Earth than we expected there on the asteroid. This is new physics. We didn't know that was going to happen. And these rubble pile asteroids are teaching us something at every step. In fact, some of these bits, which are simulants here, may behave more like little balls of styrofoam than the kind of rocks we have here. So we're going to learn new stuff by just doing basic characterization of the goodies inside this sampler head.
And one thing I think is so cool is that, you know, on Earth it poured directly into these other beaker here, but as you said, it acted almost more like fluid.
Exactly. We actually, when we took this sampler head on the TAGSAM, we pushed it into the asteroid, gave it a poke, let loose the gas and let the stuff flow. We actually penetrated 50 centimeters. That's more than almost 2 feet. So we went deep into the asteroid, fired our thrusters, and backed away with the sample intact in this sampler head. That was cool. We didn't expect that. We expected contact, 5 seconds later, grab the good stuff and come home.
Right.
So dynamic interactions, learning about how these objects work. As you heard from Lori Glaze, this is how we get to understand the worlds that we need for planetary security.
And I've even heard this described as a ball pit. That's how loose the material was when they approached Bennu.
Exactly. If we had kept going, we didn't have that smart spacecraft, all that great engineering, we could have engulfed ourselves in this rubble pile stuff. Not good. But no crap happened, and we're on the way home, and we have a sample that's coming here to the clean room right here a mile away.
All right, fantastic. Well, now that the team is bringing the SRC back to the clean room here in Utah, what can we expect?
So the next step is really important. We'll wheel that special apparatus that's carrying sample return canister with this thing inside it right to the clean room, bring it in, take off